Hello, welcome back to our little corner on the web, where we go over math problems to hopefully inspire and encourage interest in math. Today, we will go over questions 7 and 8, the 26 PMO area stage, part 1. Question 7 states that let f of x be equal to 1 minus 1 over x. Suppose that a, b, c are roots of the equation x plus f of x plus the f of x equals 26. Find a squared plus b squared plus c squared. Okay, so the first thing we'll try to do here is to expand and express this equation that we're given. Okay, so we want to be able to rewrite this in something that looks more familiar with us, for us, right? So x is just x. F of x we're given as 1 minus 1 over x. And then f of x just means that 1 minus 1 over x becomes the input here. So in essence, that's 1 minus 1 all over the input, which is 1 over 1 minus x, is equals to 26. Okay, so our job would be to get rid of all the fractions that's on the left-hand side, so that it's hopefully, given the statement of the problem, a cubic equation. Okay, so this simplifies to x plus 2 minus 1 over x minus x over x minus 1 equals 26. Okay, multiplying, we will basically here multiply x squared minus x. Okay, so we get rid of the denominators or the fractions in our equation. So we have x cubed minus x squared plus 2x squared minus 2x minus x plus 1 minus x squared equals 26 x squared minus 26x. Okay, moving all to the same side, we first have some cancellations here. This cancels that, cancels this. Okay, and then we will move everything all to one side. We have x cubed minus 26x squared plus 23x plus 1 equals 0. Okay, now we're given that a, b, and c are roots of the equation. And now we just have our normal cubic. So we can use Vieta to relate the roots. Okay, so by Vieta, we have a plus b plus c equals 26, or basically the negative of the second coefficient, meaning a coefficient of x squared, over the coefficient of x cubed. Okay, and also by Vieta, the product of the pairs, the sum of the product of the pairs should just be equal to 23. So if we're looking for a squared plus b squared plus c squared, we can try to square that and see what we find. Okay, so squaring that gives us a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac equals 26 squared, which is 676. So this is what we're looking for, right? So, but we also know what twice of the sum of AB plus BC plus AC is. That's basically twice of 23. So we're basically looking for a squared plus b squared plus c squared plus twice of 23 is equals to 676. That leaves us with a squared plus b squared plus c squared equals 676 minus 46, or 630. Okay, so that's basically it. The answer we're looking for here is 630. Okay, moving on to the next question. Question 8. Okay, a circular sector has a central angle 60 degrees. So that means that the angle that we have right here is 60 degrees. A smaller circle is inscribed in the sector, tangent to the two radius, or two radii, and the arc. A larger circle is circumscribed about the same sector as shown below. If the area of the shaded region is 2024, find the remainder when the area of the smaller circle is divided by 1,000. Okay, so we're given an area problem here. So we want to sort of relate the area of the small circle to the big circle. Right now, what's given in the problem is that the small circle is inside the big circle, right? So we can sort of write at least one identity, which is the area of the large circle is equals to 2024 plus, plus this area of the small circle. Okay, so how do we relate areas? So hopefully one of the things that you know is that the areas of similar shapes, at least two-dimensional similar shapes, is related by the square of the ratios of one of the measurements. So here, what we can potentially find is the radius, or what we can try to find is the radius of the small circle and the radius of the big circle. Okay. Let's try to start with maybe the radius of the large circle here. Let's call that R. So R in this case will be somewhere here. Okay. Given that we're dealing with a sector that's 60 degrees, there should be a triangle right here that's 60 degrees, or equilateral, 60, 60, 60. That means the circumscribed circle will look something like that relative to the triangle, where all those things are R. So if those are R, we can assume that if we call the side length of this equilateral triangle S, we can build a lot of 30, 60, 90s here, because this triangle here should be a 30, 60, 90 triangle. So this is going to be S over 2 right here. That length is S over 2, which means this length here will be S over 2 over root 3. And therefore, big R will be equal to twice that, which will be S over square root of 3. Okay, so now we've found R, the big R, the radius of the bigger circle relative to the side length of that equilateral triangle. So let's now try to find the radius of the smaller circle. So for the small circle, we know that we're given that it's tangent to the two radii, sorry. So that means that's that right angle there, and also tangent to the arc. Okay. So given that it's tangent to the two radii, we can draw this as well. Okay. And that should actually intersect right at the center of the circle. So we have two 30, 60, 90s here again. Okay. So if we call the radius little r, that should be little r. And this hypotenuse of that 30, 60, 90 should be 2r. So 2r plus this r here would be 3r is equal to the side length. Because the side length of that triangle, of that sector, sorry, the straight line on that sector, right, should be equal to a circle that's sort of going like this, right? Okay, so now we have both radius expressed as some value of s. So we can equate s's for both. So we end up with root 3 of the big R, or the radius of the big circle, is 3 times the radius of the smaller circle. So we have a ratio now, r, small r over big R is equals to root 3 over 3. As we mentioned a while ago, the ratio of the areas of the two circles should be the ratio of the square of the radius. So the area of the small circle to the area of the large circle should be equal to the square of root 3 over 3, which is just equal to 1/3. Okay, so if we let x be the area of the small circle, this equation here turns into 3x equals 2024 plus x, or 2x equals 2024, x equals 1012, and x mod 1,000, which is what we're looking for, which is when it's divided, the remainder when it's divided by 1,000. So x mod 1,000 is no more than 12. Okay. So the remainder when the areas of the smaller circles divided by 1,000 is 12. Okay. Hopefully you found these solutions helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.